Hi friends, in the series of DSA interview questions and answers, we will be covering the uh, interview questions mostly on the string, list, trees and graph, and all the standard problems we will be covering, including the recursive problems and of course the mathematical problems also, and it will be mutual learning. So let's hope for the best and let's start it.
Yeah, so let's start with the next part, my friends. uh, Let me show you where we were. Yeah, so let's start with the next part. We have seen that we have already defined the methods in the LRU cache add element and the get element. And so for that one, if we want to do the remove operations, we need to write the method right in our custom defined doubly linked list, remove node and add node at the head. So these two methods we need to define it. Rest we have already defined the implementation of the LRU cache. So for those who have not seen the implementation of doubly linked list, I will recommend please see that implementation of doubly linked list. That will be really very helpful. And it's again it's the raw one, and we have not seen any directly defined the implementation without looking anywhere else on the internet. Yeah, so let me add node at the head. So we should define these two methods, right? Remove node, add node at the head in our doubly linked list, custom doubly linked. So let's do that. So I was writing actually this public void remove node, and so before jumping into the remove node, let me go to the diagram of this. So suppose this is there, and suppose it has the data. Suppose it has the data d1, right? Now it's there, and suppose it has the data d2, and now suppose it has the data d3, right? And suppose this is the head. Suppose we want to remove this custom node. Okay, suppose we want to remove this custom node. What we will be doing is we will take this, we will get the previous node from the previous reference, and we will get the next node from the next reference. So previous node, we will set the next reference to this one, and next node will set the previous reference to this one, and we will remove this data, right? And we have already seen this kind of operations. So I think where we have done this operations, so let's ignore that one. So we will simply do this. What we will be doing is remove node, where custom node is the node. So custom node dot get next reference. Okay, if custom node dot get next reference is not null, right? So let's say custom node dot get next reference, and we put it into the next node, right? And let's say previous node, custom node dot previous node, get previous reference, and again we will say custom node previous node, right? And then what we will be doing is if there could be the chance when this custom node is the last node or the custom node is the front head node, means it's the tail node or the last node, so we should take care of that one. So what we will be doing is custom node or next node, if next node is not null, right? If next node is not equals to null, what we'll be doing is we will set next node dot previous reference. Okay, next node dot previous reference equals to what we'll be doing, the previous reference equals to previous node. right? Okay. If but there again this condition is satisfied when this is not the head node as well, right? If the head node is there, then the previous node will be null, right? So we should take care of those things. So yeah, if next node is not equals to null, and let's say and previous node is also not null, right? When there is a node at both the sides, previous node is also not equals to null. What we'll be doing, next node dot previous reference equals to previous node, and previous node dot set next reference equals to set next reference equals to okay, next node dot I should do set next node dot what was that, yeah, previous reference, next node dot set previous reference, and I should do previous node and previous node dot set next reference, I should do next node, and I should delete the data and custom node. So what I should do, custom node dot set next reference equals to null, it should be totally unlinked, and custom node so dot set previous reference null, it should be totally unlinked, right? Then this is done. Now there could be a condition when next node is null, means it's the last node, custom node is last node. If next node is equals to null and previous node is not null, previous node is not equals to null, right? So what we'll be doing for that scenario, let me delete the diagram if it's, or let me make it full screen. Yeah, now it's better. So if next node is null, means it's the last node and the previous node is not null, then what we'll be doing, we will be doing next node dot if next node is null, right? So nothing we need to do, we need to update the tail, and we need to just set the previous node dot set next reference equals to null, dot set next reference equals to null, and then what we'll be doing is tail equals to previous node, right? And then what we'll be doing is deleting the custom node which was there. So one more thing we should do while deleting the custom node dot set data, set data, and it should be null, and same thing we should do here as well, right? And then again, now there could be possibility it's the head node, and so for head node the condition will be if next node is not equals to null and previous node is equals to null, previous node is equals to null. If next node is not equals to null, okay, this is the next node. There could be a chance with the yeah, means it's not the, it's the head node when we are trying to delete the head node. Suppose g1 we are trying to delete, so next node is not null and the previous node is null, so it will be head node, right? So what we'll be doing is we suppose we are deleting d1 node, so what we'll be doing, d2 will become head, right? So d1 and d2 dot, so next node dot set previous reference, set previous set previous reference, custom node dot, yeah, set previous reference null, right? And head will point to add will point to next node, right? Add will point, so suppose this one, and we are deleting this one, suppose. So the previous reference of this will become null, and this we will delete. This we will delete, and the previous reference will become null, and head will point to this one now, right? This second one, d2. So head will point to the next node, and then again we will do the same operation, delete it. So we should write all this, the repeating method we should write all outside the loop or unlink. We should use this unlink custom node, right? So what I will be doing is I will write here unlink custom node, unlink custom node, unlink custom node, and custom node. Yeah, now in this we are doing the same thing, right? And 3 related problems, you can ignore those 3 related problems for a while. Now there could be the chance when this is the only node, right? If the previous node is null and the next node is also null, if next node is equals to null and previous node is equals to null, there could be the chance when both the nodes are null, means it is the only node which is there. So what we will be doing is unlink custom node, and then head equals to null, tail equals to null, right? This will be the logic when both are null. So this is the simple logic for the removing the node. There could be more modifications. So let's see what the 3 problems it has identified. Doubly linked list dot remove node. So we will see what the problem it is saying. So let me remove the diagram for the clarity. Yeah, remove node, existing node. Doubly linked list, remove node, custom node, and custom node. That's right. And what is the error it is showing here? Remove. Why? Why it's showing error there? Remove node in doubly linked list. So which is our doubly linked list? Custom collection dot doubly linked list, remove node, and where I have defined the doubly linked list. Okay, so we should change the import. Actually we should change the import. I have defined it into our custom, so we can put copy dot, and then it will work. So this I prepared in order to make the videos. So yeah, remove node. Now what is the error it is giving? Cannot resolve symbol existing node. Okay, that's interesting. Existing node. Okay, here it's taking. So doubly linked list dot get last node. Okay, so we will fix these errors. Now we have to put a new method, add node at the head, right? Add node at the head. So let's do that. Add node at the head, public void. So this will be quite simple, right? Add node at head, add node at head. So what we'll be doing is custom node and custom node. So again there will be how many cases? there could be the chance when head node is so there again add node as a head will be again add similar to the this one, add list, add to the list at top, everything will be same. So I will just copy this, most of the things will be same here. Add node at the head. Now no need to define the custom node here. Size should be incremented, that's true. If head is null, add node at the head. So we are returning void, so we'll just put nothing. If just put return, and if head dot previous reference equals to custom node, so if it's null, then head and tail should be initialized, right? We have already seen this logic in the doubly linked list when we are defining. If the both are null, we should define head and tail. If both are not null, head dot previous reference equals to custom node, and custom node dot set next reference equals to head, and we should update the head and then return. Yeah, head will be pointing to the first a node which will become the next node. So head dot set previous reference is the custom node dot set next reference to the head, and then we will update the head and we'll return. So add node at head is done. Okay, simple as that. And then here when we are removing the node also, we should decrement the size. So size minus get next reference that get previous reference, previous node, next node, and then size minus, right? We should decrement the size as well. Okay. Wait, before decrementing the size, we should check first thing first. If head is equals to null, if head is equals to null, return, right? Or head is equals to null, or or remove node equals to null. So we should return simply. So then only we should, otherwise we should proceed. So this way it should be best. Now we have add node at the head also. Now let's go to our LRU cache and see what add node at head. So this method is still not defined, so let me put here. Now it should be defined there, LRU cache. Now remove node, so last node, it should be last node, right? Doubly linked list dot get last node. Now we should define one more method, which is the doubly linked list dot get last node. And what we want to do with the last node, we want to remove the last node, and then okay. So super, we should just return the tail. Get last node means we should just return the tail. Doubly linked list, add node at the head, public void last node, get last node. So last node means it should definitely be not node, so not void, custom node it should be, and then last return tail is where the tail is pointing, right? It should just return the tail. Where is the error it is showing? Okay, one related problem that we can ignore, no need. of LRU cache. So we should put last node here, and then is there any error which is coming? Yeah, all fixed. So in the doubly linked list one problem is there. Let's find out and fix it. What's the problem? Showing. Cannot resolve the symbol. Okay, custom node, remove node. So custom node dot get previous reference, and then the okay. So this was, I will just instead of custom node I will do, and then it should fix custom node equals to null, right? So now all the errors have been fixed. Okay, we have add, remove element. These are all the previous methods which we were defined in our custom list, custom doubly linked list. So remove node and add node at the head and get last node. So we are done with the implementation of LRU cache, right? So yeah, get element, add element. What we are doing in the add element, again simple. We will update the priority. If it is the last, we will remove the node and add the node at the head. Anywhere it is there, we will add the node at the head, and then if the size is greater than the size which was there, then we will remove one size from the last and one element from the last of the doubly linked list, which is the least priority, and then we will put a new node at the starting. And so that's all the logic we have done. Now we should optimize this code, optimize or refactor this code. The repetitive things, basically we should put it into a new method. That part we will be doing. And in the add element, we forgot to increment the size, so let's add increment the size as well. Get is not null. Doubly linked list dot add node at head. Remove node. If it is already there, no need to increment the size, just return. If its size is there, then no need to increment the size. So only for last case we will, here we can, since we are removing one node as well, so no need to increment the size. Here we can increment, before returning the size we can increment the size plus plus. Okay, so that's done. Now we can write this dot size plus plus or whatever we want. Now add element is done, get element is done. We will not remove anything from the get element, and here we need to add the null check as well. Get key is not equals to null, so I think map will take care of that. So yeah, but still we should not create the, so if key is equals to null, then what we will be doing is return. Simple, no need to do any operations. So now we have done with the implementation of LRU cache, and I will recommend to see the doubly linked list video if you have not watched the doubly linked list video. So yeah, now next in the next part we will run and execute the doubly linked list, LRU cache.